Can you hear me, Professor?
Yes, we can.
Okay.
Okay, what was the first point again? Was 0 and 1, right? Second one was 3 and 3. And we were working on the third one. What did we have for the third one?
3.
No, what did we know? Something was missing here. So we completed this, we completed that. Let me see if I still have the problem. So the problem was, okay, so that was the problem.
Yes, 3.
So we finished this one, we finished this one. Now we're gonna do the third one. So -3, and we're missing y. So again, same thing, we're gonna take -3, we're gonna plug it into the equation and find y. So dy is 2/3 times x, what's x again?
-3.
That's right, it goes here. So x is given, so this is x and this is y, plus 1. So y is, again, cancel. What's -3 divided by 3? -3 divided by 3 will be?
1, -1.
Negative, that's right,
One.
-1 plus 1.
Plus 1.
And simplify, it's -2 plus 1, which is -1.
1.
So that was the first part of the question. So this is -1. So -3 and 1. So all these pairs are complete. Second part of the question is to graph. Okay, we're going to graph this. So we're going to need this time we're going to need a two-dimensional graph because we have x and y, two coordinates. We're going to need rectangular graph. We're going to need something like this. Okay, one axis for x, the other one for y. X and y axis. Put some numbers here, some positives. Got some negatives here. And then positives here, negatives
When
down.
you do that, you always start from 1, right? You don't put 0, right?
And the center is 0. So the center
It's
is 0.
Gotcha. Okay.
So
Okay.
1 here, 2. Same thing here, 1, 2. And here we have -1, -2. Also -2 down here. Then we're just going to plot. We're going to plot all these points. Each one of these pairs is a point, so 0, 1. Then 3, 3. And -3. And 1. Let's start with the first one. So again, the first one is x. The second value is the y. So let's graph or plot 0 and 1. So we're going to start from the x. Always start from the x on this axis, the horizontal one. So 0 will be in the center. Then you want to go to y. So y is here. So from x here, you go to the y. So if the y is positive, you go up. If it's negative, you go down. If it's 0, you stay on the x-axis. So for this one, so we're going to start from x0, which is here. Where do we go from here?
You go up to 1
That's right, we go up once.
on
It was
the
negative.
same line.
That's right, so from here, so start from 0, go up once, and that's it. That's the first point. That's A. Let's call this one B, and this one C. So this is point A. Okay, then you want to go to the other point. So this is go to B this time. X is 3, Y is 3. So again, we're starting from X3 on this axis. It's positive, so it's got to be on this side. Okay, so that's 3 here. Where do you go from here? We want to go to y. Y is positive 3. So where do we go from this point?
3 up.
Going to go 3 up. If it was negative, it would go down.
It will
If it
go
was
down.
0, you'll stay here. If the y was 0, you'll stay right here. So in this case, start from 3, x3 on this axis. You're going to go up 3. So it's going to be 1, 2, and 3. So that's the second point, B. Finally, C. What do we start this time?
-3. You got to start at the bottom.
That's right. I'm going to start from negative
Yeah.
3. On what axis? X or Y?
This is Y.
No,
Oh,
negative
this
3.
is X.
X.
X. Yeah.
Going to be here. On what side?
On the left
On
side.
the left side.
Because it's X on negative 3 here. And then we get, what's the Y?
-1.
1. -1.
No,
So
the
go
1. Here. What is the 1?
No, but you have the equation there right there. It says -1.
Yeah.
Okay.
You didn't
I
write
don't know why.
-1.
Yeah, you're right. I don't know why.
Do not put the minus.
Missing a negative here. That's right.
Yeah.
The point is negative on it, right? So again, we start from negative 3 on the X, which is here. And we go where?
Down 1.
Down.
Y.
No, once.
Mhm.
Because this is -1. Okay, so the point is here.
Okay.
So let me just write this. So -3 is here. So we start from here, go down once. Start from -3, go down once. And this is point C. What do you notice about these points? A, B, and C.
The line.
There, that's right. They're all
It's a
belong to
slant,
the
a
same line.
diagonal line.
Exactly. So because it's a linear equation, this is a linear equation here. That means when you graph it, all these points are basically points that belong to the same line. So now, once we plot those points, we just need to join them with the same line. That's how you know everything is good, because the points all end up on the same line. If for some reason the line is not straight, let's say one point was here, another one was here. So the third one should also end up here, not somewhere over here. So this is not a line, looks like a triangle. This is wrong. One of the points is wrong. Either this one is off, should be here, or maybe this one is wrong, should be in the middle, or maybe that one is wrong, it should be over here. So all your points must be on the same line. If you miss one sign, or if you make a little mistake like we did earlier, one of these points will be off the line and it won't be right. So but that's a way to check. So if one of the points is not good, go back and check here, or check all the, basically when you plug it and solve, make sure you check and make sure all the signs and everything was correct. Okay, so that's what we mean by complete the pairs and graphing the line. This was 3.2, question number 16. And for the homework, you're doing 15.
Question 13, Professor, 13.
What does it say?
It's question 13, not 16.
13 here, okay. So that was 13. All right, you guys got that, everybody?
We're so good.
Yeah,
All right.
good.
Jermaine, you there?
Yeah, I think. Mhm.
Okay. Just plug. Again, each pair has X and Y. You want to plug what you have and find the other one. Sometimes you might be given the second one. If you have, for example, this, that's the Y. So if you know the Y, you plug it into the Y, for example, here, and then find the X. So depending on what you have, plug the value that you have and find the other one. Okay. At the same time, let's take some attendance. Everybody signed in the board, right?
Yeah.
Okay. Hello, Maury, good made, Angel, Leva, Santiago. All right, so let me call you for attendance. Leilannette, you
Yes, I'm putting down a different, this is a different problem, but hold on, because I'm writing the one that we actually gave us the homework with. I got to put a different one on.
okay.
Give me a second. My apologies.
All right, so let me go to.
Professor, it's just out of curiosity. We had an older gentleman that was in the class. Is he
Anthony.
on here too? I'm just curious.
Anthony, what about him?
Oh, I was just wondering if he has been in his Zoom classes. I don't know why, I was just wondering.
No, I've never heard from him. He never showed up. I've been emailing him and everything. That's Anthony. I don't know. Not really sure, but I always send emails and stuff.
Okay.
Yeah. Just hope he's okay.
Yeah.
So Professor, the equation is x minus y equals 3 and x plus y equals -1. The question is solve each system by graphing. If the system is inconsistent or the equations are dependent, say so.
Okay. All right, let me finish the attendance and I'll check that. So Asadova, not here. Anthony, not here. Geneva. Ayana is here. Antonio, 1, not here. Santiago, Anna. And Shadley Cruz, Jose, Malik Megranez is here.
Yes.
Ori was here. Karima just now. Jermaine is here. Angel.
Yep.
Okay. Leilannette is here. Rohan, Quentin, Diadra, Sadukat. Sadukat is or was here. All right, so the other next question is,
That's exercise 4.1.
4.1, and the question was? Which question is this?
You need me to read it again? It's question number 24.
That's not for the homework.
No, you gave us 23.
Okay. I said the system. So that's a system. We have two equations, not just one. So this makes what we call a system. System of two equations. So we want to solve this by graphing. That means we need to graph both lines. You see here the previous example, we graphed only one line, one equation, this one, into this. But this one has two, so we're gonna have two lines in the same graph. We're gonna have this one like this, another one maybe like this, for example. And the intersection of the two, if they meet, will be the solution. So this will be S, if they meet. If they don't meet, then it's a different scenario. So let's go back. So we're gonna graph both of them, just like we did. We're gonna put both in the same graph and see if they meet or not. So let's start with the first one. Start with X. So line 1 is this one. So just like we did earlier, so we see here how we had incomplete pairs that we had to complete. This, this, and this. If you're not given incomplete pairs, you can make up your own. You can always do this. Do at least 2 points. So start the first one, put the 0 in the y, and the second one, put the 0 here. Then just complete both of them, find the other value. This is what we call when the y is 0, this point is called the x-intercept. Okay, and when the x is 0, this point has a name. It's called the y-intercept. Okay, so if you don't have a table or pairs, feel free to use yours. These are the easiest one to use. Just start 2 pairs, put 0 in the y, that's called the x-intercept, and then the y, 0 in the x, this point is called the y-intercept. And then complete them. So we're doing this for both lines, right? So we're doing this one for now, that's line 1. Once we're finished with line 1, we're gonna do line 2. All right, so look at this equation here. If the y is 0, if you plug the 0 here, what would the x be? If you plug this into this. Right? If you plug the y value, this is the y, so this is x and y. If you plug here, what would the x be? This will cancel, right? Because it's a 0, so x will be
3.
3. That's right, so the x will be 3. Now, let's see what happens if x is 0. I mean, if x is here, right? This will be what? We need to find. So for the second time, this x is 0, so we're going to put 0 here. So 0 minus y will be 3. And then you solve this for y. What's 0 minus y? Just ignore the 0. Would be negative y. 3, and then we divide by?
Divide by 1.
That's right, negative 1. Think of this as negative 1.
Negative 1, excuse
Negative
me.
1. Negative 1. So y is negative 3.
Negative 3.
That's right. So now the value that's missing here is 3. So that's for first line. So let's graph it. Again, we're going to need a graph. So this line will go over here. So we're going to put the line here. So x and y as usual. Then some numbers here. Okay, so the first 2 points, 3, 0. Where do we start from again? 3, 0. We want to put that in this graph. What do you do? Start from where? From 3, which is here. And then where do you go?
You do y, but y is 0, so it stays in the middle.
That's right. So we start from x3, which is on this axis. That's here. And the y is 0. So we're not going up. We're not going down. We're staying right over here on the x-axis. That's the first point. Then let's graph the second one. Where do you start and where do you go to graph this point?
Well, you have to put -3 because it's a -3, the answer.
That's right, for this one, right?
Yes.
Right. Okay, so let's graph this point, 0, -3. Where do you start and where do you go?
The x
the
is
y-axis.
0, so it stays in the middle, and then you have to go you have to go down -3.
That's right. So always start from here, from the x, which is 0. The 0 is always in the center, and the y is -3. So from there, we're going down. We're not going up. So we're going to go down to -3. -3 is somewhere over here. So start from here, go down, and that's it. So that's the first line. Let's use a different color for that. So
This is just for the first equation for x minus y equals 3?
Exactly. That's just one line
Okay, okay.
because it's a system of two. So we just
Yes,
finished this one. Now we're going to do the second one. So let's call this line 1. I'm going to repeat the same process as we did, but this time with line 2. So we're going to go to, let's write down this equation, x plus y and -1. Same thing, so we want to start with 2 empty sets or empty pairs, well, incomplete pairs. So I'll start with the first one, that's the x-intercept. So the x-intercept again is when the y is 0, then you're going to put 0 here and it will be the y-intercept. All right, so let's look at this equation closely. This is the y. If we put the y here, what would the x be? If you put the y 0 here, this turns into 0. So what would the value of x be?
-1.
That's right, that would be -1. Because if you substitute this with 0, it would be -1. Now for the second one, we have the x. If we put the x here, if you substitute it, this cancels. So the y will be?
-1.
That's right, it would be -1. Very good. That's it. We have 2 points. We're going to put this line on the same graph as well. It's a system, it has to be on the same graph, not separate graphs like we did earlier. All right, so let's start with the first one here. So -1, 0. Where do we start and where do we go?
0 on the x-axis.
No, first we're going to start from the x.
-1.
So the x,
-1 on the x.
Okay.
where would the -1 be? On the left side,
Right here.
right?
Negative side.
That's right. Where do you go from here?
You stay there because it's 0.
That's right, because the y is 0, so we're not going up, we're not going down, we stay right on this line. Now, that's the first point. Now let's do the second one, 0 minus 1. Where do we start again? Where do you go?
From 0, you go to the -1.
The x,
Negative side.
-1
you go down 1.
on the y-axis.
Y.
That's right. We start from 0 and go down, because it's negative, go down to -1. That's the second point. Well, this point and this point, what do you do next?
You put a line. You put the line in there.
That's right.
Cross
Because
the
you have to
line.
make a line through these 2 points.
Mhm.
So it's going to be something like this. There you go. I'm just going to say line.
2.
Good. So where is the solution again? What's the solution? Give me the location, not the actual numbers. Just what do you think the solution is? The intersection,
They
right?
meet, but not but they meet, but not directly in the way. I don't know.
So they meet, right? So the where they meet is the solution. So this is basically the intersection of the two
-1.
is the solution. So we just need to get the coordinates of that point. What are the coordinates of that point starting with the x? So drop this over the x-axis. This will be, what's the x here?
1.
1.
1, comma, what's the y?
Negative.
-2.
-2. Very good. So you're going to put -2. That's it. That's the solution. The pair -1, -1, -2. That's how you solve a system by graphing. There are other ways of solving systems, but this is one of them, and it's graphing. So you got to graph both lines on the same graph and see if they meet. If they don't meet, you just say no solution. Sometimes it may end up like this, parallel. No intersection, so no solution, if you end up with something like this. Okay, so that's a no solution. That make sense, everyone?
Yes.
A little bit.
Okay.
Little, yes, exactly.
Okay, so again, just
So
graph.
from this equation, we have to write no solution if,
Yep.
if it's not
Yes, if they
solution.
don't meet, you say no
Okay.
solution. Okay. So just graph both lines, just like we did a couple of times, and get that intersection. It doesn't have to be accurate. Sometimes it might not be very clear, but just try to read it as clearly or as precisely as possible. Okay, so that's basically the method of graphing.
So what if it is a solution, like if it is, I guess, complete or something? Like what would the coordinates be where you have solution 1 minus 1?
I'm sorry.
What would be when it is a solution?
For this
The
problem?
solution would be, I guess, where the lines meet. That's what it
Yes.
was in, 1 and then -2.
So this is a solution here. See that?
Okay.
So that's the final solution. So the intersection of the two lines.
Okay.
If they meet. If they don't meet, sometimes you may end up with parallel lines like this.
Okay.
They don't meet,
Gotcha.
so
Okay.
you say no solution if they don't meet. Okay, but most of the time you'll see an intersection. Just try to read it as like I said before, as precisely as possible. It might not be accurate, but just get the closest coordinates. For example, here, 1 and -2. Okay, so that's the solution we're looking for. Okay, everyone? Everybody got this? Everybody else? Ayana, Migranez, Mari?
I'm gonna give you another one.
Other
Or
one.
do you want somebody else to go? I said, do you want me to give you another one, or do you want somebody else to go?
I would prefer maybe somebody else to go. Because
Oh, they're probably saying the same thing I have in mind. So let her go ahead. I'll take it.
okay.
I'm stuck all the way, so anything you put up there might help.
All right, so let's see how much time we have left here. Let's do another system. Okay, so all right, let me make up another problem.
Yeah, let's clean up the board too. Sorry.
Okay, I want to leave it here just in case you want to come back to it. It stretches really well. It's good. I like it.
Oh, okay.
It's unlimited board.
But you did not put it. It's you recording the meeting, but there's no way for me to go in there and see it.
I'll at least save the pictures, or you can save them. If you see them, you can maybe take screenshots of it. But I'm gonna save
That
the
I'm
picture.
doing, but then with the snap, the taking a screenshot does not give me your voice explaining it.
Right. It would be better, yeah, if, maybe if...
But I think you do have a setting on there, because when we go on your class, it's showing you whether to have, to see previous recorded meetings. If you turn that on, we might be able to see it.
That's right. There is an option for that, yeah.
Yes, so please turn that on so we can probably go back in there and see.
Yeah, I'll look into
Later.
it. So let's do this one here. 3 and maybe 2x plus 2y and 6. Say, let's again solve by graphing. Okay, same question. Solve by graphing. So we're going to start with each line, x plus y. Okay, and we're going to start with 2 pairs. What do we put in each pair?
X intersect and Y intersect.
So 0 here, and here 0. Okay. And then we're going to do the same thing for the second line, plus 2y. And we're going to do this. Same thing, 0 and 0. Okay, just by looking at the equation, if y, this is y. If y is 0, what would the x be?
3.
X would be
3.
3. And here, If x is 0, that's x. If x is 0, the y will be
3.
3. So for this
I don't
one,
understand how I got this.
how you
I
got
don't
what?
understand how I got that. Well, I'm answering the question, so I don't understand how I'm actually understanding it. I'm sorry.
If you answer, that means you understand it. That's good.
Yeah, that's what I'm
Okay?
saying. I don't understand. It doesn't compute. Why am I understanding it? This makes no sense.
Just believe in yourself, okay? You got this. Don't overthink it, okay? That's it. If you can
I
answer
am
it,
overthinking it. I am overthinking.
no,
I'm sorry.
don't
Go
overthink.
ahead.
Okay, same thing here. So this is the y, right? If you put 0 here, right, this cancels. It will be 2x. This cancels, right? If you put the 0 here, this goes away. So 2x equals 6. That means x is what? X is
3.
6.
3. If you divide by 2, divide by 2 would be 3.
Oh, okay.
Okay, same thing now. If the x is 0, if you put the x here, this cancels out, right? If you put 0 here, this cancels out. So you end up with 2y equals 6. All right? And what do you do from there? What is y?
X.
Same thing, you
Oh,
divide, it's 3.
It's 3. That's it. So the first line, 2 points. Second line, 2 points. What's left to do? What do we do next with these two?
plug
The
it.
question
Plug it
was,
Do the
in.
graph.
in the graph, that's right. The question was to graph the system of two equations solving by graphing. So that's, again, the x. So this is the x-axis, the y. I'm gonna put some numbers here quickly. And a few numbers here as well. Okay, so 3, 0. We're gonna start from 3 and do what?
0.
So start from 3, that's 3, and stay over here because the y is 0. And this one, x is 0, that's here. And then where do you go?
3.
Up to 3. So you go up to 3. So that's the first line. Let's draw that line through the 2 points. Okay, so let's call that line 1. Okay, so this is line 1. So that's line 1. Then we're going to repeat the same thing with the second line. We have the 2 pairs. We have this one, and we have that one. So we're going to put those on the same line as well. So 3, 2, 0. This is, by the way, this is just an arrow. It's 0 here. So 3, 0 will be where again? It will be on the same. Will be the same point, right? As you can see, these 2 points are the same. So we're going to put the other point over here as well. And the second one also looks like it's the same point as the previous line. So this is line 2. So also 0, 3. So it'll be here.
Yeah.
So let's draw the line. Basically, it's the same line. So the first one was green. Second one is
Hello.
yeah, let me actually use the straight line instead. It looks like basically the same line. What do you notice about these 2 lines?
They are the same.
They're the same. That's right. They're the same. Basically, we say they overlap. On how many points do these lines meet? Because the solution is usually the intersection of the 2 lines. With the earlier we saw in this problem here that the 2 lines meet in 1 point, so there's one solution, right? And also said earlier that the lines might never meet when they're parallel, so there's no point of intersection between the 2 lines. There's no solution. But this case is different. How many times do these 2 lines meet? On how many points do they meet, in other words?
On the The X and the Y.
2 times?
Is that the only times they meet? What about here and here and here?
Oh my God.
They meet everywhere, right?
Yeah.
So how many
Okay.
solutions do you think we have?
Infinity and beyond.
Very good. That's exactly
Oh
right.
my God, I'm telling you, I don't understand how I get this. This makes no sense.
I told you, believe it yourself. You know more than you think you know. Okay. So basically, the line is the same line technically. I just multiplied one equation by 2. I took the same equation, times it by 2. Basically, it gives you the same equation. So the two lines overlap. Therefore, we have infinitely many solutions. Okay. Infinitely many solutions because the lines are extend infinitely, and there's so many solutions, an infinite number of solutions.
Professor, but when you have to find X and Y, you always start off with 0?
You always start from the X coordinate, right? It's easier that way, yeah. So start from the X coordinate and go to the Y, or you may start from the Y and go to the X as well, but probably better to start from this axis, locate the X coordinate, and then from that X coordinate, you go to the Y vertically, either up or down or 0. You stay on the X axis if the Y is 0. Okay, you guys got that? Makes sense?
Yeah.
Jermaine, Leonette, Angel, Ayana, Maury.
Just, I'm not saying anything. Just watch me in the camera.
Okay, all right. I'm not seeing the camera right now. I'm just seeing the chat. I have so many open windows here. So I have my whiteboard and the chat open in other websites, Blackboard and attendance and everything. All right, so that's got about 2 minutes left. So any other questions before we call it a day?
I think the homework 12 that I was having the issue with, now that I see the explanations, I think I might be able to go back in there and
Okay,
give it a try.
this was mostly from homework 12, yeah.
Okay, good.
So like I said, just go over the, as you study, as you do your homework, any complicated questions, just any from the book or from the ebook or the homework itself, just write them down, take notes, and when we meet, we go over that, and just like we did here on Zoom today. Okay?
Can I ask, Professor, how many classes you have a day?
How many classes a day? Anywhere from 2 to 4.
Okay, so if in between your classes, I wanted to have a Zoom meeting with you to explain something, I can?
Yeah, I'll email me and I'll give you the other, my schedule, similar classes for math too. You could join if you have time. Okay, so I have a total of 7 classes per week. Each class meets twice, so it's 14 sessions a week. Okay. But just email me, I'll by the way, there is the schedule for the next semester is available. If you want to be in the math in college algebra, you can request me by name if you want to be in my college algebra class. I already got my schedule. I have classes all over the place, so check with your advisor.
You said for college algebra?
Yeah, see which class or schedule.
Yeah, I'm already registered, but I need to ask request for you.
So you're also teaching for the college algebra, right?
Yes, I'm teaching about three sections of them.
And you have class Tuesday and Thursday?
Yes.
Okay.
Okay, Friday and Thursday, 2 classes. So check with the advisor. They will give you my schedule and see where you fit. Okay. We're running out of time. We've got about a few seconds left. Email me if any other questions. Join the discussion board. Until then, I'll see you on the Zoom meeting in a couple of days. Okay.
Okay. Thank you.
You guys for coming. Stay safe. Stay sound. And all right, no problem. I'll see you soon. All right.
Okay.
Have a good day.
Thank you.
All
You
right.
too.
Bye.
All right. Take care.